Dear viewers, welcome to the UGC lecture series in biophysics. Today we are going to learn about hand propagation in the field of direct methods. This is a continuation of the earlier path. So, we have stopped at one stage, now we are going to continue in part 2. As continuity, I just want to mention that direct methods use the such effect amplitudes directly obtainable from experimental methods after measuring the diffraction intensities, and after having some assumptions they get phases through some special combinations like structure invariants or structure semi invariants. Here the exact phase or the actual phases can be obtained by using a method known as tangent formula. So, using the known magnitudes and the structure invariants or phase relationships, individual phases can be obtained. Once you have the individual phases and the normalized structure factors corresponding to the point atoms, a map called E map can be calculated. It is just like Fourier map. Instead of the spherical atom contributed structure factor amplitudes, we are using point atom contributed normalized structure factor amplitude. That is why it is known as E map. To do an E map, we need phases. In the absence of computers, we have been seeing how these phases have been obtained using hands, because they did not use any computer. So, now as a continuity of whatever you have seen, let us take the block 15. Block 15 contains parent reflections as 1 bar, 2 bar, 11 bar and 2, 0, 5 bar. When you add this reflection H and reflection K, corresponding H indices have been added. 1 bar means minus 1 plus 2 1, minus 2 plus 0 minus 2 2 bar, 11 bar is minus 11, 5 bar is minus 5. So, 16 bar. So, these are, as I mentioned earlier, parent reflection, daughter reflection. Same daughter reflection can also be obtained by different means. 3 bar, 6 bar, 11 bar is a reflection, 4 4 5 bar is a reflection. When you add, you get this. So, same way is assuming you know the signs of this 1 bar, 2 bar, 11 bar and 2 0 5 bar, we have seen that sign of H plus K is simply the product of the signs of H reflection and K reflection. Okay. Now, in block 16, if you see here, I have the reflection 1 2 bar 16 bar. This 1 2 bar 16 bar was a daughter reflection obtained from different series of parent reflections. As I told you in the beginning, these daughter reflections, even though it was obtained by 3 different parent reflections, it should have the same sign. If there is a problem in different signs, then you have to change the entire starting set of reflections called origin depending reflections, start from the scratch. Now, look at block 16. Okay. Here 0 2 10 is there, 1 2 bar 16 bar obtained from this result is there. This result gives you C as a sign for 1 2 bar 16 bar. This C can be plus or minus. Okay. Now, the 0 2 10, if you look at our origin different reflection, this sign has been assumed as A. This result is obtained from here as C. Therefore, sign of 1 0 6 bar has to be A multiplied by C. So, A C. Why I am telling is, do not always expect a single sign for the daughter reflection. It may be plus or minus or symbols, because A is a symbol plus or minus, C is a symbol plus or minus, but if we get an answer A C, just put it as A C. Finally, we will evaluate the symbol. Once A B C D symbols are known, A C will be known. Right. Now, this is what I mentioned here. This sign of A C will finally be evaluated at the end of the sign propagation. Once the value of the symbol A and C are obtained as plus or minus, we will see it towards the end. Now, we can proceed as such, right. Let us say I have found sign of H reflection as AC, like double symbol, product of two symbols, and sign of K is plus. Therefore, sign of the reflection H plus K will be AC times plus, which means AC only. Now, let us say sign of H is AC and sign of K reflection is minus. You again use the Sayes relation, sin of H plus K is sin of H multiplied by sin of K. So, AC into minus, therefore, answer of sin of H plus K is minus AC. A can have plus or minus, C can be have plus or minus, we will give some sign, exact sign, minus AC is the final sign of H plus K. Now, here comes a little bit of complication, do not get confused. Sin of H is B, sin of K is BC. So, when you add H and K reflection, you get H plus K reflection. So, sin of H plus K reflection will be product of sin of H and sin of K, which is B multiplied by BC or B square C. Now, what can be sin of B? Either plus or minus. Whether B is plus or minus, B square is always plus. Therefore, the product sin of H plus K sign is simply C. Clear? It is actually B square C. B can be either plus or minus only. Therefore, B square is always positive. Therefore, sin of H plus K is C. Now, let us say if sin of H is AC, if sin of K is ACD. So, in the process you may be getting it, because I am not going through every block. I am going to give you as a homework, final assignment. You can copy it and try to see from the set of your 3 plus 5 reflections, 3 with symbols plus plus plus, and the remaining 5 as A, B, C, D, E, like that. You proceed your calculation of hand propagation. Finally, I will tell you what is the result. So, since H is AC sin of K is ACD, then when you add H plus K, sin of H plus K will be sin of H multiplied by sin of K, that is AC multiplied by ACD, which is A square C square D. So, A is plus or minus, so A square will be positive, C is plus or minus, C square is positive. So, final answer is only D. Now, suppose sin of H is AC, one deflection, and sin of K is BD. So, do not confuse. So, this will be the first block of 31, here 31. So, we have AC will be there, then BD will be there. So, when you add it, I get 3 4 bar 7. So, this reflection will be having a sign multiplication of AC and BD, we get ABCD. So, just keep it as ABCD. Okay. Now, we have here another block. This is your 106 bar, this is AC, this is BD. So, this will be 3 4 bar 7 ABCD. Now, consider another set of parents 0 10 bar 8. So, that will be ACD. 3 6 1 you will be getting answer B. Again you are getting multiplication ACD multiplied by B, we get ABCD. So, using this different reflections as parents, I am getting answer for this reflection as ABCD, again different reflection ABCD. This means that since you are different parents and same output is getting a daughter, if you are getting same answer for this different pathways, it means that you are proceeding in a right direction. So, once you proceed the same way as I have been mentioning, you can get the symbols or propagate the signs up to block 64, no problem. If in the process of hand propagation, as I have been repeatedly telling, if contradictory signs occur for a reflection, then that reflection should be removed from the origin fixing reflection list and the new process should be continued. That is why in those days, in the absence of computer, when people have been doing this calculation by hand and also assigning of intensities by visual estimation, so many all are complicated. As I told you in the first lectures, when you have 1000 spots of different blackness, fixing numerical value is very difficult. Darkest spot you can give 100, but based on that only you have to imagine thousands of spots, that is one thing. Then second complication is the hand propagation. Now, let us consider block 50. Okay. In the example we are considering now, in block 50 the sign of 3, 2, 5, right, from all these blocks 1, 2, 3 will be BC. Here we get an answer BC, here also we get an answer BC, but here we get an answer CD. What does it mean? How to interpret? Same reflection, BC is obtained, okay, BC is obtained, okay, fine, but here I am getting CD, which means that since it is same reflection, the symbol BC should be equal to CD. So, CC cancels, I have to get B equals D. What does it tell you? Even though you have the choices of choosing B and D either as positive or negative, now we have a restriction on the sign of B and D. Sign of B depends on sign of D. If you take B as positive, D should have positive. If you take B as negative, D should be negative. In other words, the signs of B and D should be same. So, this is a beautiful result we obtained using hand propagation, right. Even though you are flexible to assign signs to symbols plus or minus, now we have a problem. You cannot say B is plus and D is minus. No, if B is plus, you have to assume D as plus. If B is minus, you have to assume D as minus. This is a new result. So, now finally, using this hand propagation, what the results you have achieved? I have achieved B as D. In one result, I achieved A equals BD, and another result I obtained BD is positive. Correct. When you say B equal to D, B has two choices, positive or negative. When B is positive, D has to be positive. So, BD has to be positive. When B is negative, D has to be negative. So, again BD is positive, fine. In terms of B and D, once you fix the sign of B and D either plus or minus, suppose I say B is plus, automatically D becomes plus. Since A is BD, A becomes plus, right. Suppose I say B is minus, so D is minus, A has to be BD, minus times minus plus, clear. So, this is the way now you are fixing the symbols of A, B, C, D, E. Okay. Now, individual A, B, D can have two choices, right. Now, we have the answer only regarding A, B and D. C, we did not get any answer in the process. So, therefore, C you can take either plus or minus. So, let us see what will happen in the table. Let us when you fill it. No, now we have B equals to D. So, now two choices, B is plus, D becomes plus, B is minus, D becomes minus, because B equal to D. Since you say A equal to BD, B plus D plus, therefore, A has to be plus, B minus D minus, therefore, this has to be plus. Now, in both the cases, C can be either plus or minus. So, now we have four choices for A, B, C, D alone, right. One set says plus 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 A, B, C, D, other is plus minus A, B, C, D, other is plus plus minus plus, then other is plus minus minus minus. According to this set A, B, C, D, you can get remaining 495 reflections or whatever reflection you face, no, symbols will be there. If you take this as A, B, C, D, we have another set, this is another set, this is another set. That is what we are telling. Direct methods are multi solution in nature. For every set we can have a combined figure of merit, then whichever is having the largest value as per Shelley program, that is the best set. So, this is called hand propagation. Now, whatever I given the table, I am explaining clearly here. When B and D are given plus, right, and if they are given same value minus, since A equal to BD, A is filled plus sign. So, we get rows. C can be either positive or negative. So, we can put C as plus, we get 2 rows, C as minus, we get 2 rows, that is all. So, this is the explanation of the table. Now, in case of non-centrosymmetric case, it becomes the question of assigning phases. Centrosymmetric, we talk about simplest phase group P 1 bar, triclinic 1 bar inversion symmetry. Same triclinic we can have P 1 phase group where there is no symmetry. P 1 phase group is the simplest example for a non-centrosymmetric phase group. Here the origin depending reflections are chosen and their values are assigned either 0 or pi. We can add some more reflections and also have the phases 0 or pi. Whenever you assign 0 or pi, those reflections have to have at least one of the H, K, L as zeros, right, because these are called centrosymmetric reflection. So, in a separate lecture series, I will explain you how to choose these origin defining reflections, right. Now, so this is the formula we are going to use. Phase of H reflection plus phase of K reflection is nearly equal to phase of H plus K reflection. Now, whenever you invert a reflection H to H bar, the phase will become minus, that is phase of H will be minus of phase of H bar, or phase of H bar will be minus of phase of H. But if your phase of H is 0 or pi, this minus 0 becomes 0 or minus pi becomes plus pi. Therefore, in this case phase of H bar is same as phase of H. So, this is a clue you have to use in the phase propagation, because centrosymmetry is called sign propagation, this is known as phase propagation. Here also two parent reflections H and K are added to get you H plus K, phases are added. Previously centrosymmetric signs are multiplied, that is the only difference. So, here I am giving you the whole table as an exercise. So, this is German structure, statistic, whatever I given, no, everything is given. This is the starting point. So, we are assuming 3 reflections and the phases have been assumed using origin definition, and other reflections I am assuming symbols A, B, C, D, E. They can be plus minus, plus minus, plus minus, plus minus, plus minus. Finally, you are going to evaluate these symbols. According to that, whatever rest of the reflection other than these 8, no, whatever we have taken in the propagation, those will be having answers in terms of this only. Once you fix the symbols, the rest of the answers will be with you and you can do the rest 0 or pi, that is plus or minus. Okay. So, this is the formula we are giving and I am giving you entire list here. Okay. It is a homework. If you are very much interested, you copy that origin defined reflections in your hand and go through it and slowly fill it up. It is very easy. So, you have a satisfaction of how people solve those structures using the hand propagation. This is for P 1 bar. So, it is an interesting job, we are going to see. As I told you, everything depends on the origin defining reflections, right. We are going to prove later that there are 8 types of origin, and when you move from one origin to another, then there is a phase factor coming in the structure factor. Suppose you say my origin is 0 0 0, you have to see that during the entire process origin is not moving from 0 0 0 to other 7 types of origin, and this origin shifting can be avoided by fixing the sign of 4 reflections in such a way that if the origin is shifted, at least for one of the reflection the sign will change. So, that is the principle of origin depending reflection. So, the origin reflection has to depend on the parities. So, like that. So, we will take a separate class to show what should be the parity of those reflections to fix the origin. So, that your coordinate system, everything you are getting finally, they are unique to a particular origin and there is no shift in the origin during the process. So, that will have a separate lecture. So, these things you can interestingly do this assignment, right. You just copy and sheet, the origin difference 3 plus 5 reflections, and remember the lecture or again re-listen to the lecture and complete this. So, this is a very good homework, you will enjoy. So, in summary what we have seen now is we have introduced Sayer's equation and the sign relationship. We have given the tutorial how to do phasing both in centrosymmetric and non-centrosymmetric group manually, that is called hand propagation method. So, we need the reference, original reference for this is the Sayer squaring method, a new method for phase determination, published in Acta Crystallographica volume 5 1952. There are 8 centers of symmetry in the unit cell. First is known as 0 0 0 origin, this is known as half 0 0 along the a axis or x direction, half of the unit cell is cut, then 0 half 0 along the b axis center, then 0 0 half along the c axis middle point. Okay. These are the axis. Then with respect to the faces you can have the centers half half 0, then half 0 half, then 0 half half, then at the center of the body half half half. So, there are thus 8 centers of symmetry in the unit cell. The question is, when you move the origin from one centers of symmetry to another centers of symmetry, what will happen? So, for that is a simple mathematics. We will take the structure factor equation, which is always referred to origin 0 0 0. Structure factor definition is F h equals summation j equal to 1 to n. N is the total number of atoms in the unit cell. F j is the atomic scattering factor of the jth atom, which varies with respect to sin theta by lambda like an exponential decay curve, multiplied by e power 2 pi I h x j plus k y j plus L z j. This h k L are Miller indices defining a Bragg plane, and x j, y j, z j are the final coordinates called fractional coordinates you are determining for the jth atom. Once you determine this x j, y j, z j for all atoms running from j equal to 1 to n, now you know the positions of all atoms constituting the unit cell. Once you know the position, we can get the 3-dimensional picture. Okay, that is the ultimate aim. Now, when the origin is moved from 0 0 0 to half 0 0, right? Now, what are you doing? When you say 0 0 0 represent x j, y j, z j system, half 0 0 means you are shifting this first point from 0 to half. 0 means x j. So, since it is half shifted, now we are shifting from x j to x j plus half, that is you have to remember that. So, otherwise it is simple. When you denote f h 0 0 point as x j, when 0 means x j. So, half means 0 plus half, therefore, x j to x j plus half, that is it. Now, just remember this exponent. This exponent is of the form e power a plus b plus c, is nothing but e power a times e power b times e power c. Anytime we can expand and again join together. Let us take the first term e power 2 pi I into h x j plus half. This can be expanded as a product of two terms e power 2 pi I into h x j times e power 2 pi I multiplied by h multiplied by half. Okay. The second term half, these two cancels, we get e power pi I h. So, what is inside remaining? E power 2 pi I h x j. Already we have e power 2 pi I k y j, e power 2 pi L z j. So, entire thing now becomes e power 2 pi I h x j plus k y j plus L z j. Since this e power pi I h does not depend on j, the summation index, I can take it outside. So, this result is nothing but e power 2 pi I h multiplied by this result, which is same as f h 0 0 0. But whenever h is an integer, this is trigonometric formula e power pi I h equal to minus 1 power h. Okay. Now, we see that when the origin is shifted from 0 0 0 to half 0 0, there is and introduction of a phase factor, right. If you are clear about this derivation, I can now go to the shift from 0 0 0 to 0 half 0. Shift is along y direction. Now, so here instead of this x j plus half, x j will be there. Now, instead of y j we have y j plus half, multiplying factor is k. So, now we will be getting f h 0 half 0 will be minus 1 power k like this. Then f h 0 0 half will be minus 1 power L f h of 0 0 0. So, when there is only one shift along either a axis or b axis or c axis, we have the introduction of the phase factor multiplying the original structure factors. One k is minus 1 power h, other is minus 1 power k, other is minus 1 power L, right. Now, same argument we follow. Suppose I shifted from 0 0 0 to half half 0. Now, x is shifted from 0 to half, y j is shifted from 0 to half. So, now we have two terms here, instead of x j plus half, instead of y j here we have to give y j plus half. So, now we have two phase factors coming out from this exponent, one is e power pi I h, other is e power pi I k. So, finally, we get minus 1 power h plus k. So, what I am telling you is that whenever this origin is shifted from the parent origin 0 0 0 to some other origins, we have a phase factor coming out. Now, we have like this origin 8 types of origin, we have the reflections HKL having 8 parities. For example, I can say this as odd, 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 or even, 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 right, odd, even, 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 odd, odd, like that 8 parities are there. Now, how to choose the reflection, or from what parities you have to choose the reflection, so that the origin will not change from one to the another, because now we have seen that when it is changing, phase factor is coming. So, without change of anything, can you fix the origin to one place, let us say 0 0 0, by choosing proper set of reflection? Yes, it is possible. By choosing specific parity of reflection, let us say 4 reflections, and assigning particular signs, I can keep the origin fixed at this point 0 0 0. This is known as origin fixing. So, again we will deal with this topic in detail. These reflections are given in the list when you do the hand propagation. Whatever reflection that has been given symbols plus 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 something, these are known as origin fixing reflection. We cannot take all the reflections from even, even, even parity, no, not allowed. I will give you the reasons also when we take the next module. So, by knowing a limited number of reflections chosen for origin fixing and one reflection for inertium of fixing, then we can face the rest of the reflections with the knowledge of these 4 reflections, but each reflection can have a phase value 0 or pi, inertium of will be having plus or minus pi by 2. So, this is how we can do the phase calculation by hand. Once you know everything, you can calculate E map. What we need is modulus is coming from your experiment, only phases are unknown, phases are coming by hand propagation. I know modulus and phase, we can calculate E map and get the structure. So, this is how in 1940s to let us say 70s people have been doing, because automation came in the year 1972 only. Until then only with hand people have been using. 72 the first automated program came from University of England, and the program name is Multan. That MULTAN, that MUL signifies that direct methods are having multiple solutions. Tan signifies that tangent formula gives you the individual phases. So, this is why they have given the name Multan, the first automated program that came into existence in 1972. So, now I am sure that you will appreciate both the mathematics, the direct methods, and this method of solving by hand, which will give you invoke your interest in the field of X-ray crystallography. Now, everything is automation. By pressing a button, you can get an answer. It is not necessary to know what are structure invariant, what are semi-invariance, what are origin dependent reflection, everything, but we have to honor those people who have spent years together, no, right, decades together in developing these methods. So, that is why I am teaching you the fundamentals also, so that you have courage within yourself and you can read those papers if you are very much interested on the probability distribution of the structure invariance, semi invariance, like that. So, I thank you so much. So, what we have learnt in this lecture series is that what is Sayer's equation, what is squared electron density in a centrosymmetric structure, how you can assign the signs of bulk of reflections from a knowledge of the signs of a small set of reflections, then how you can assign the phases of reflection for non-centrosymmetric, assuming in the phases of some origin depending reflections, and also how to choose this origin depending reflection, what should be their parity. So, I thank you so much. We will see in detail about origin fixing in the next lecture series. Thank you so much.